operations video. In this one, we're going to look at solving equations that are 2 or 3 step equations. And by that I mean equations that have 2 or 3 numbers on the side of the variable. So if you look at this equation here, there's 1, 2, 3 numbers on the side of the variable, so it would be a 3-step equation. And these are a little bit harder to solve using opposite operations. But then again, they're a lot harder to solve by inspection, so this is kind of why we introduced opposite operations, to solve things like this. Before we look at using opposite operations to do that, I just kind of want to look at this, and we're going to work backwards to really see what's going on. So we start here with n. We know we're going to do a whole bunch of operations to n, and we want to get 3 as our final answer, because it equals to 3. Well, what operations are we doing to n? First, we multiply it by 2, and we get something. Then, we subtract 5, and then we divide by 5. So what we're going to do is we're going to work backwards to kind of figure out what n is. Now this takes a little bit longer, but we're going to see a little more of what's going on. So what would we divide by 5 to get 3? Well, that would be 15. So we know at this stage right here, it would evaluate to 15, because 15 divided by 5 is 3. Now here, what would we subtract 5 from to get 15? Well, that would be 20. Okay, now what did we multiply by 2 to get 20? Well, that would be 10. So we know that n has to be 10, because 10 times 2 is 20, 20 minus 5 is 15. 15 divided by 5 gives us 3 as our answer. So we kind of solved that working backwards, which is really what we do using opposite operations. Now notice, on this side we did all these operations. Over here, what's the opposite of dividing by 5? Multiplying by 5. 3 times 5 is 15. So instead of sitting there and going, what divided by 5 equals 15, we could have just done, well, 3 times 5 gives us 15. Same thing here. We could have just added 5. 15 plus 5 is 20, because that's the opposite of subtracting 5. Same thing here. The opposite of multiplying by 2 is dividing by 2. 20 divided by 2 gave us our answer as 10. So we're kind of working backwards up our ladder using opposite operations to get our answer. And that's really what we do when we solve using opposite operations. We work backwards from the end back to our beginning using opposite operations. Let's look at this example. We want to solve this 2-step equation, 3t minus 4 equals 2, using opposite operations. So remember, our goal is to isolate the variable. So sometime at the end, we want t equals something. We want t to be alone. Now, in 2-step equations, obviously there's 2 numbers on the side of the variable that we need to get rid of both of them in order to get the t alone. So the question becomes now, which do I move first? Do I get rid of the subtracting by 4 first, or the multiplying by 3? Now if you remember what we just looked at, we're working backwards when we solve equations. Now if we were going forwards in evaluating an equation, we would use BEDMAS. But since we are working backwards in solving equations, we would do BEDMAS backwards, or SAMDEV. So normally we would multiply by 3 first and then subtract 4. But since we're working backwards, we need to get rid of the addition and subtraction first. So we use our idea number 1. The opposite of subtracting 4 is adding 4. And I do that to both sides of the equation. Now, minus 4 plus 4 is 0. The reason we added 4 is because we knew those would cancel out. And the only thing that's left on this side of the equation is 3t. Now 3t equals, on this side, 2 plus 4 is 6. So once we got rid of that minus 4, now there's only one number on the side of the variable. It's a 1-step equation. Now we get rid of that. What's the opposite of multiplying t by 3? Well, we divide it by 3. And I divide the other side by 3, because whatever I do to one side, I have to do to the other. Now multiplying by 3 and dividing by 3 are opposites. So we're left now, just like we wanted, t on this side. We've isolated the variable. On the other side, 6 divided by 3 gives us So we get that t equals 2, solving this equation using opposite operations. The new thing now, though, is once we have a 2 or 3 step equation, more than one number on the side of the variable, the order we get rid of them, the order we use operations, is BEDMAS backwards, or SAMDEP. Let's look at a couple more examples to practice using these 4 things now. Our goal, to isolate the variable, our 2 main ideas, every operation has an opposite, every root on one side has another, and now we've introduced that if there's more than one number on the side of the equation, we use reverse BEDMAS, or SAMDEB, in order to move the numbers. Let's start over here. 5 times b plus 3 equals 20. Our goal is to get b alone, but it has this 5 and this 3 on the side with it. Which do I move first? Well, brackets go last. So this 5 is being multiplied into the bracket, so it goes first. It's here at m. So the opposite of multiplying this 5 in is dividing by 5. And I make sure I use idea number 2 and do it to both sides. So those cancel out, and we're left with b plus 3 equals 20 divided by 5 is 4. So once we move that 5 over, now this new line is a simpler equation. It just has one number on the side of the b. And we can move it by subtracting 3 from both sides. Plus 3 minus 3 are gone, and we're just left with b equals 4 minus 3 is 1. So you get b equals 1 as our answer. Now, a lot of times we want to check our answers to make sure we're right. In our next video, we'll go back and look at how we can check to make sure we're right. On a test, you may want to know, well, I don't know, did I make a mistake? But there's always a way we can know that this is the right answer. Next equation, t minus 3 divided by 5 equals 4. Now, we have a minus 3 and a divided by 5. Which do we move first? Well, it says to use subtraction first here. But when we have an equation written like this, it's like the numerators and brackets. Another way of writing this is t minus 3 divided by 5 equals 4. So really, we move our divided by 5 first because we do brackets last. So opposite of dividing by 5 is multiplying by 5. They cancel out, and now we're just left with t minus 3 equals 4 times 5 is 20. Now the opposite of subtracting 3, adding 3 to both sides, and we're left with t equals 23. And again, in our next video, we'll go back to this example and look to see, to make sure that 23 is the correct solution. Alright, hope you've had a chance to now stop and pause and try these for yourself. Let's take them up. Start over here. We have this negative 3 and this minus 2 on the side of the x. We need to move both of them. Which do we get rid of first? Well, we do brackets last because we're doing BEDMAS backwards, so that's minus 3. So what's the opposite of minus 3? A lot of people would say plus 3. But remember, is this minus 3 being subtracted from the x? No, it's being multiplied to the x. It's whatever the number is doing to the variable. And this is, if we used our distributive property, would be negative 3 times x. So the opposite of multiplying by negative 3 is dividing by negative 3. And they cancel out, and we get x minus 2 equals negative 9 divided by negative 3 is positive 3. And now we add 2 to both sides. It's a 2, trying to be a 2. And we're left with x equals 5 as our solution for that. Okay. The next one, square root of x plus 4 equals 3. Now, even though you only see one number here, this is really a two-step equation because there's 2 operations. We have this plus 4 and the square root. And which do we get rid of first? Because I don't see the square root in BEDMAS. Well, I guess it would be exponents, but we do plus 4 before exponents. Again, just like in fractions, whatever's on the inside of your square root is really in brackets, so we do that last. And we get rid of our exponents first, which is a square root is kind of like an exponent. So the opposite of square rooting is squaring. So square root and square cancel out, and we get x plus 4 And then we subtract 4 from both sides, and then we've isolated x, so we get x equals 5 is our solution.